Bismillahirrahmanirrahim. Come to the second part of this topic, which is the arc length. And as we stated in the first part, the arc length can be evaluated or commuted by the formula integration of from a to b of the square root of 1 plus f prime of x, where f prime is continuous on the given interval. F prime is continuous over interval a to b. Then we can say the length of the curve y equal f of x, where x is between a and b, is given by L equal to the definite integral a to b of the square root of 1 plus f prime square. Or in the Leibniz symbols, we can say that L equal to the integration a to b of square root of 1 plus dy by dx square dx. In some cases, the curve is given in the form of the equation x equal to g of y, where y is between c to d, and g prime is continuous. In this case, we can write the arc length formula as integration from c to d of the square root of 1 plus g prime square, or dx by dy square. So either we can do it as x prime or y prime. So it is integration of the square root of 1 plus x prime square or y prime square, dy by dx square or dx by dy square. For example, for that we need to find the exact length of the given curve, where y equal to x to the power 3 divided by 3 plus 1 over 4x, and x is between 1 and 2. To find the arc length, first we should find the derivative for this function. I will have y prime equal to derivative of x to the power 3 divided by 3 is equal to x squared. 1 over 4x, applying the coefficient rule, this can be written as minus 1 over 4x to the power 2. This is the derivative for this function. It is x squared minus 1 over 4x squared. Now, if we square it, because we need the square root of this form, or this one, dy by dx square, the y prime square is equal to x squared minus 1 over 4x to the power 2. That will give me is equal to the power 2. I will have x to the power 4 minus 2 multiplied by x squared multiplied by 1 over 4x squared plus 1 over 16x to the power 4. This will cancel this one. I will have minus 1/2. That is x to the power 4 minus 1 over 2 plus 1 over 16x to the power 4. Now the arc length, which is given by L equal to from 1 to 2, these are given in the problem. X is between 1 and 2. Integration of 1 plus y prime square, which is equal to 1 to 2. I will add this one to the minus 1/2. I will have 1 over 2 plus x to the power 4 plus 1 over 16 x to the power 4 dx. Now combining everything there with the common denominator, this will be 1 over 2. I wrote off. Multiply 16x squared by 1. I will have, and simplify 2 with 2, I will have 8x to the power 4. It will be 8x to the power 4 plus 16x to the power 8. This with this one plus 1 divided by dx. Or this can be written as 1 to 2. The numerator is 4x to the power 4 plus 1 all to the power 2, because this is perfect square. Actually, it is a plus b square. I have square there, and this is 2 times the square root of 16, which is equal to 4. So it is 4x to the power 4 plus 1 all to the power 2. Divided by this numerator can be taken out as 4x to the power 2 dx. So we will have integration 1 to 2 of 4x to the power 4 plus 1 divided by 4x squared, which can be written as 1 over 2. Now 4x squared divided by 4x squared, so 4x to the power 4 will give me only x squared. And 1 divided by 4x to the power 2 dx. Now integration, or integrating this one, I will have the first one, it will give me 1 over 3x to the power 3. The integration of 1 over 4x to the power 2 will give me 1 over 4x. Now since it is definite, we can evaluate it. I will have 1 over 3. It will be 2 to the power 3 minus 1 minus 1 over 4 multiplied by 2 plus 1 over 4 multiplied by 1. Because it is negative, it will be positive at the end. So I'll have 7 over 3, and this is 1 over 8 plus 1 over 4. That will be 7 over 3 plus 1 over 8. This will give me 59 over 24 length unit. So this is the arc length for the given curve over the interval 1 to 2. It's 59 divided by 24. Have another example. For that, I want to find the arc length for this curve x equal to 1 over 3 square root of y multiplied by y minus 3, where y is between 1 and 9. This function can be written as x equal to, if you open the bracket, I will have 1 over 3 y to power 3 over 2, because this is 1/2 times 1, and then 1 times 3, I will get minus square root of y. That is 1/3 y to power 3 over 2 minus square root of y. The derivative for this one, you can say dx by dy. So just differentiate. I will have dx by dy is equal to, the derivative for the first term will be y to power 1 over 2 y to power 1/2 minus the square root of y will give me 1 over 2 y to power 1/2 or minus 1/2. Now if we square it, dx by dy square, it is written as x equal to, as a function of y, so we need to find the derivative with respect to y, not with respect to x. So this is equal to 1 over 4, if I square it, the identity a plus b all to the power 2, which is equal to a squared plus 2ab plus b squared. I will have the square of the first term, it is 1 over 4 y minus 2 multiplied by the first term, which is 1/2 y 1 over 2. The second term, which is 1/2 y to the power minus 1 over 2 plus the square of the third term, which is equal to 1 over 4 y to the power minus 1. This is equal to 1 over 4y. So I'll cancel this one. I will have, and also this 1/2 or minus 1/2. So I will get only minus 1 over 2 plus 1 over 4 y to the power minus 1. Now the arc length, which is equal L equal to, was from 1 to 9. The limit given 1 to 9 of square root of 1 plus dx by dy square is equal to, add this one to minus 1/2, I will have 1/2 plus 1 over 4y plus 1 over, not as 1 over 4y down in the denominator. Now combine all of these. The common denominator is 4y. Is over 4y. So we multiply the first one by 2y. So it is 2y plus y square plus 1. We combine the, or find the common denominator, I will have 2y plus y square plus 1 divided by 4y dy. Again, we multiply the first one by 2y, second one only by y, and third one is plus 4y. So this is equal to integration from 1 to 9. The numerator is a perfect square. So it can be written as y plus 1 to the power 2 over 4y. Again, this is perfect square. So the integration now can be written as 1 to 9. It is 2y plus 1, looking outside the square root divided by 2 square root of y dy, which is equal to 1 to 9 is 1 over 2 y to the power minus 1/2 multiplied by 2y plus 1 dy is equal to 1 to 9, give me only y to the power half. Just will cancel this one. Just we multiply this with the first term, and with the second term, I will have plus 1/2 y to the power minus 1/2 dy. And this will give me the integration for the first one is 2 over 3 y to the power 3 over 2. And integration of the second one is only square root of 1. Between 1 and 9. Just evaluate it. I will have a 3 over, or 2 over 3 multiplied by 9 to the power 3 over 2 minus 1. This is the first term. Plus, second one is square root of 9 minus square root of 1. So I will have 2 over 3. This will give me 27 minus 1 plus 3 minus 1. That is 27 minus 1 is 26 times 2 is 52 over 3 plus 2, which is equal to 58 over 3 length unit. So this is the arc length for the given curve x equal to y or 3 1/3 is equal to y times y minus 3. On what we did, we opened the bracket, simplified, then we found the derivative dx as with respect to y, not dy by dx, because written as x equal to a function of y or d of y. So what we found is dx by dy, we square it, we plug it in the formula, and then we evaluate the integration.